Afternoon everybody. So today we are starting our second lecture on introduction to probability. So today we will start with conditional probability. Conditional probability is basically a thing which already happened. That's mean you are finding the probability of an event A. Look at this one. When you know that the B event has already occurred. So this is written as probability of A given B. Now, if you are finding this probability of A given B, look at this, B is already happened. So you are finding the part of A in B. So that can be represented as a common portion of A and B. So that's why probability of A intersection B in the numerator, which is your in favor, and in denominator the total one probability of B. So that's the way you are finding probability of A given B, which is you can read as probability of A conditional that the B has already occurred. Secondly, you can do this for the B given A, same way it is B intersection A, which can be written as A intersection B as well, both are same, and denominator it will be probability of A. Next we go to an example for that one. Look at this, gender and grades. In a large class, the probability of randomly selected a woman is 0.6. So if you are writing this one, that this is B is the event that it is an woman, and a woman, then probability of B is equals to, you will get 0.60. This thing you will get. Next, look at this, the probability of randomly selected a student who is a woman and who earned an A is a grade is 0.2. That's mean here both things have to be happening. A woman as well as she should earn an grade capital A. So that's why it is intersection of the event B, and if we take A is earning and grade A, then it is A intersection B. So if you are writing this one you will get as probability of A intersection B, this is equals to 0.20. Now, if you randomly select a student, randomly whenever you are selecting a student, it may be a woman, may be a man. What is the probability that she earned an A grade? So you are finding the probability. Look at this here. You are finding the probability of A given B. So you are finding the probability of earning A grade when you know that it is earned by an woman. So this thing we have discussed here. This is 0.2. This is 0.6. So you are writing probability of A given B as probability of A intersection B by probability of B, and which is equals to 0.33. One thing you can note that the probability of the conditional probability is always less than the probability of the denominator. It's happened since it is not the sample space, it is a part of the sample space. Next, look at this, and in percentage it is 33.3%. Another example, if we are giving for a deck of card, look at this. In a deck of card there are 52 cards, and I think we have discussed in our first part that there are 4 strips are there, and there are 2 color, black and red. So what is the probability that a randomly selected card is a club? Okay, club, given that it is a black card. So how many black card you have? Black card is equals to half of the total cards. So that's why the probability of black is equals to 0.5. Now the club probability is equals to 1/4, because there are 4 strips are there. So 4 is the total number of strips, which are diamond, hearts, spade and clubs. So now if it is a club and black, means it have to be club, and you know that the clubs are always black. So total number of card equals to 13. Total card in a deck is equals to 52, which is 0.25. Now if you are finding the probability of a club when the black cards are given, you can find it by probability of club intersection black by probability of black, which is equals to 0.5. One thing you can notice that if you are finding the probability of clubs, no condition is given, then it is 1/4 equals to 0.25. Means probability of clubs equals to 0.25. And if you are finding the probability of clubs, when a condition is given that the clubs, means the cards are already black cards are selected, then you are finding that the probability equals to 0.5. The conditional probability is always greater than the simple probability. Next one. Now we will discuss the total probability. Let me discuss with an example. Look at this. This is a box, box 1. This is another box. This is box 2. Let it contain 3 white ball and 5 red ball. It's contain 4 white ball and 7 red ball. Now what is happening here? That one ball is transferred from box 1 to box 2. Okay, one ball only. I am not writing any color here. So the color is not known to you. Now you want to find a red ball from the safe box. And what is the probability of this one you want to find. So what is happening? 2 boxes are there. One color, 3 white and 5 red ball in box 1 and 4 white and 7 red ball in box 2. One ball is transferred from box 1 to box 2. You don't know the color. Now you want to draw a red ball from the second box. This is the cases you are doing here. Now look at this. If I am writing that probability of W1 means drawing a white ball from the box 1, then total number of white ball is equals to 3 and total ball equals to 8. So this is 3 by 8. If you want to draw a red ball from the box 1, then it is by the same way 5 by 8. Okay, no problem with this one. Now if you are finding a red ball from the box 2, I am writing this one as probability of R2. Look at this. Since you don't know the color of the ball which one is transferred from box 1 to box 2, you have to consider it may be a white ball is transferred, then you have drawn a red ball from the second box, or maybe a red ball is transferred from box 1 to box 2 and then you are finding the red ball from the box 2. Both things you need to consider. That's why, since all cases are considered, that's why it's named as total probability. Now look at this. This will be a white ball is transferred from box 1 to box 2. Then you are drawing a red ball from box 2 when you know that a white ball is transferred. Okay, plus probability of R1 that a red ball is transferred from box 1 to box 2. Then you are finding a red ball from box 2 when a red ball from box 1 to box 2 is transferred. It is known to you. So this is the way you are finding the probability, and you can easily find the result. If I am writing here, then probability of R2 equals to, look at this. This is equals to 3 by 8. Now one white ball is transferred. You have to believe this. This is already transferred. So total number of white ball is equals to 5, and total ball also increased by 1, which is 5 plus 7 equals to 12, plus now one red ball is transferred, which is 5 by 8, and total white ball, sorry, I have written wrong here, 1 minute. White ball is transferred, so red ball for finding, we are finding the probability, so it is 7 by total 12 plus a red ball from box 1, 5 by 8 into, now a red ball will be increased, so it is 8 by 12. So in total you will get 7 into 21 plus 40, so 61 by 96. This is the probability of drawing a red ball from the box 2. This is happening here. So here are 2 exercises we have. Let me solve one of them at least. Problem first one. A light bulb manufacturer has 3 plants. A light bulb manufacturer has 3 plants. Plant 1 accounts for 50% of the daily output. Plant 2 30%. Obviously, plant 3 will be 20%. Nothing to mention here. So if we take let A1 for plant 1, A2 for plant 2, and A3 for plant 3. C. Okay, these are the three events we have considered. Then probability of A1, since it is 50% production is giving AO, so it is 50 by 100 means 1/2. Probability of A2 30% means 3 by 10, and probability of A3 is equals to 2 by 10. Okay, let me write this 2 by 10. Okay. Come back to the topic. Question: the percentage of defective bulbs produced by the three plants is 2, 4 and 9 respectively. Mean we are finding the defective bulbs when it is produced by plant 1, it is 2. So let D be the event that is defective bulbs. Now probability of defective bulbs when it is produced by plant A, it is 2%, 4% and 9%. So it is 2 by 100, 2 by 100. Probability of defective bulbs from plant 2, it is equals to 4%. So 4 by 100, and probability of defective bulb from plant C is equals to 9%, or not 9 by 100. Okay. Next, look at this. What is the probability? This is the question. A bulb is selected at random and found to be defective. That's mean you know the bulb is defective. This is known to you. What is the probability that it was produced by plant A 1, 2 or 3? So let us do this. Bulb is defective, bulb probability will be 5. So probability of defective bulbs. Look at this. Defective, before it to be defective, it have to produce. So we are deciding this one produced by plant 1. Then it is found to be defective, which is the probability here. So probability of A1 into probability of D given A1. This is complete case for the plant 1. Next, probability of A2. Then it is defective bulbs from A2 plus probability of A3 into probability of D given A3. This is the total probability of finding. So if we want to do this one, then it is A1 means 1 by 2 into 2 by 100 plus 3 by 10 into 4 by 100 plus 2 by 10 into 9 by 100. Okay. So if we are taking this one as 10 multiple, then this is 1000. So 5 into 2 10 plus 3 into 4 12 plus 2 into 9 18. 30, 40 divided by 1000. So it is 1/25. This is the probability as a total probability. Going back to the topic, the question was, what is the probability that it was produced by plant 1, 2 or 3? That's in the case of Bayes theorem. So we'll discuss after this one how we can find this one. So we are starting the Bayes theorem. So as we discussed the total probability lastly, so in our last case we have discussed how to find the total probability from unknown thing happening in our first case. In second case we are finding the probability. In Bayes theorem, what you need to remember that a thing is already happened, previously happened, and you know the result of that, the case of the second, you are finding the probability of the previous case. So there will be term related to Bayes theorem will be used as was, where. Then you have a mind that it may be Bayes theorem we have to use here. Let us go for an example. There are 3 jars contain color ball. I described in the table. Look at this. The jar 1, 2, 3. Jar 1 contains this number of red, white and blue ball. Also jar 2 and 3. Now one jar is chosen at random and a ball is selected. So which jar is chosen, it is not discussed here, and a ball is selected. Which ball is selected, that is also. If the ball is red, now If the ball is red, I mean this thing is known to you. What is the probability that it came from? Look at this. This is what I previously told you. Past tense will be it. It came from second year. Then you have a mind that it can come from the base year. So if we discuss this one, look at this. That we will define the following event. That J1 is for the first year, J2 second, J3 third, and R is the event that it is a red ball is selected. Now J1, J2, J3 are mutually exclusive because they have nothing in common. And next one, because of this, our simple sample space has been divided or partitioned along these three events. Now look at this in Venn diagram, jar 1, jar 2 and jar 3. The selection of jar 1, jar 2, jar 3, because they have nothing is facility about any jar. So the selection procedure will be equal for them. So that's the probability of any jar is equals to 1/3. Now if you are finding the red ball from jar 1, jar 2 or jar 3, that means you are selecting the jar 1, then you are taking the red ball from it, jar 2 selecting, then you are taking red ball, and it's complicated as jar 3 and you are selecting red ball. Same way the event it can be divided as jar 1 you are selecting and not red ball, R complementary not red ball, it will be happen for jar 2 and jar 3. Now look at this. This says probability of A intersection B is equals to probability of A given B into P of B. This is called product rule. You can simply look at this. You can easily find the conditional probability as probability of A given B equals to P of A intersection B by probability of B. You can remember this is coming from the conditional probability. Next, look at this. That jar 1 you are selecting and you are taking a red ball, and that's why it is intersection. That means you are selecting the jar 1, then you are finding the red ball from jar 1. So jar 1 you are selecting is 1/3, and number of total red ball in jar 1 is 3. Total ball is equals to 8. So that's why its probability equals to 1/3. This will be samely happen for jar 2 and jar 3. I think you can do this. This is easy to do. Next, I'm coming to the last one. That if you are finding the probability of selecting jar 2 when it is a red ball, it's known to you, then what you are doing? That you are selecting the jar 2 and you are getting the red ball, that is in your favor, and probability of R in probability of selecting a red ball, which is the total case, which can be happen that from the jar 1 and a red ball, jar 2 and red ball, or jar 3 and red ball. That's why it's plus. So you can easily finding the probability, which one is already found before. So 1/8 this is for the jar 2 and red ball, 1/18, sorry, 1/8 is for jar 1 and red ball, jar 2 and red ball is 1/18, and jar 3 and red ball is 4/27, which is giving you 12/71 is the probability which you are finding by the Bayes theorem. Now these are the test questions you have. Let me solve one of them at least. Another set of questions are there. So let we do for the first one. Okay, 3 persons A, B, C are being considered for appointment as president of the company. Their chances of being selected are in the proportion 4:3:3. The probability of a public issue being floated, if selected, is respectively 0.3, 0.5 and 0.8. Now, what is the probability? Let me write the question. What is the probability that the public issue raised when A is selected? This is the question. Let it do this. So first of all, A, B, C are the three persons are there. Their selection is in the proportion 4:3:3. So let me write the event first. So let E1, A is selected, E2, B is selected, E3 is C is selected. Okay, and the P is the event that the public issue raised. Since they are in 4:3:3 in this proportion, so probability of E1 equals to 4 divided by total 10, 4 by 10. Probability of E2 equals to 3 by 10, and probability of E3 equals to 3 by 10. This is the selection of these three persons. Now that how there, let us look at the data. Okay, that their chances of being selected are in the proportion 4:3:3. The probability of a public issue being floated is 0.3, 0.5, 0.8. So 3, 5, and 8. Okay. So the public issue is raised when E1, when A is selected, is 0.3. Public issue is raised when B is selected, is 0.5, and public issue is raised when C is selected, is 0.8. These are the probability. Now, if we are finding that the public issue is raised, then it is coming from the total probability. It came from A, B, or C, from these three persons. So first of all, A is selected and the person raised the public issue, okay, plus probability of E2 when B is selected and B raised the public issue, plus C is selected and C raised the public issue. So look at this. This is equals to 4 by 10 into 3 by 10. Let me take in decimal, so in fraction, it will be easy for calculation. Plus 3 by 10 into 5 by 10 plus 3 by 10 into 8 by 10. So in total it is 100. So 12 plus 15, 27 plus 24. 27 plus 24 is equals to 51. So this is the total probability. Now if we are finding the probability that it is coming from the third one. So what you have to do, that probability of E1 when A is raising this issue, when raising this issue is known to us, this is the base theory. So this is total probability and this is the base theory. Okay, so this is probability of E1 into probability of P given E1 by probability of P. So this is 4 into 3, 12 by 100 divided by 51 by 100. So you are getting as the probability as 12 by 51. 12 by 51 is your answer. This one. This is for the first person, meaning if A is selected. If you want to find it for B, then you can replace this numerator by E2 into probability of P given E2, and if you want to find it for C, then E3 into probability of P given E3. That's the simple way to find the base theory. You can solve the previous questions which one you have here. Okay, and another questions also here. So you will be familiar with base theory. This is the first part we are finishing today. Next day we will start the probability distribution. Thank you.